that I'm adding to the motion unit, but actually isn't part of the motion unit. It's information you need to do your lab. Uncertainty is, I can say this with certainty, that if you take university physics, you'll spend a lot more time on this than, but I try to give an introduction to it in the grade 12 course. And what it is, it's the idea that every time you measure anything, there are always going to be some inaccuracies. For us in the lab, you know that, right? There's not very high standards on precision in the high school physics lab, particularly Miss Stone's high school physics lab. But as if you moved into an experimentation in a university level lab, and especially in more the master's level, I mean, uncertainty it's critical, right? Especially when you're measuring things very, very tiny. Knowing how far off you can be is important because it actually affects, right, what you might report as an accurate answer. And certainly as an engineer, understanding your uncertainty is very critical because, what if your plus minus on one of your measurements puts your bridge, for example, into a state of instability? You know what I mean? If your measurements on your heights and lengths puts you into a point where your bridge is no longer stable. It's very critical to understand uncertainty. So there's a lot of emphasis on it in university. I just try to use it in the labs. And from your point of view, I find kids generally understand why they do it. They get it. It is a pain. It is a pain. And certainly the bigger the lab we do, the bigger pain it is. So, like I say, even if you're the most accurate measurer in the world, you're only as accurate as half of the precision on your instrumentation. And looking at this example, if you're measuring this on, say this is a meter stick and you're measuring to the millimeter, the most accurate you could say is maybe within half a millimeter. You could not possibly be more accurate than that on this piece of instrumentation, which is pretty accurate for the high school physics lab, but I would be amazed if you could be that accurate. But in when you're talking about, say, subatomic particles and things that are so tiny, it's really important. Or another one, like I say, in the high school's physics lab, there's this, but we also have tons of error just on our reading. So for example, say you're using a stopwatch. Well, you're going to be off on your timer. There's a reaction time built in on how far off your measurements are going to be. Right? So really when you report time for anything, it's never the time, it's the time plus or minus your measured time plus or minus your reaction time and your instrumentation error, right? So what I like to see in your grade 12 lab reports is a range of answers. I don't want a straight answer from whatever you measure for your height or your distance or whatever it is. I want to know a range. What is it actually? So, we'll go through an example, and I find you'll get it right away. It's not very difficult. So here's an example. Say Ferd wants to know Mima's average speed as she scooters up Main Street. So he measures out a distance of 200 meters, but since he uses sidewalk squares, there's plenty of variation in the lengths. He figures his length measurement is really anywhere from plus or minus 4 meters, right? He says 200, but it's really plus or minus 4. Because he figures he could be off by 4 meters in either direction. And every time you do a lab, I want you to think about every measurement you take. How far off plus or minus could I be? And you can make the estimates. I'm not going to make those for you. But you decide how far off you could be, and then you're going to get an answer in terms of range. Same with his timer. So he's measuring how fast she goes. He's saying with his reaction time, he could be off plus or minus a whole second. So that means when he measures 365, he's really got 364 seconds or 366 seconds. So he wants to find her average speed with uncertainty, right? So the maximum possible speed occurs when you have the maximum distance and the minimum time. Because if you look at you're looking for speed, so distance and time. So the biggest number, v, will be the biggest d, but the smallest t. So when he does that calculation then, he's going to use 204 meters, because here's his 4 measurements, high and low. We don't care about the center one very much. We care about the highs and the lows, right? And that works out to be 0.6 meters per second. Okay, so he uses the highest possible d, the lowest possible t, and that would be the maximum speed she was going. Quick note here on decimal places. Decimal places are it is important to have an idea of how many decimal places. We've talked about it before, significant figures. There's a scientific proper way to do it. In our labs, typically because we don't use scientific notation, I look to see a decimal place that fits with the number of decimals you're using in the question. So, usually use the minimum. Now, for example, when you're dealing this case, though, it wouldn't be really right to say 1 meters. That's a big change, right? So if these were really big numbers, if it ended up being Vmax was 64.6 meters per second, I would probably expect you to respond 65. Because we're looking at numbers less than 1, you should keep 1 decimal place. Okay? This is an important note. Write that down, and if you're not sure when it comes to your lab, just ask me and I'll help you. Okay? For minimum speed, though, you can imagine you just do the very opposite, right? It's going to be your lowest numerator and your biggest denominator, and then you get 0.5. So her speed isn't whatever the middle number is. I guess it'd probably be 0.55 or something. But her speed is going to be this range between 0.5 and 0.6 meters per second. And that's how I want to see your responses in pretty much all your labs that you do, right? And trust me, this was an easy example. It can be. Sometimes you have to do 5, 6 calculations to get to your final answer. So it's pretty annoying to have to do it. It doubles your calculations. But it does give you a more genuine answer, right? It's not true to say 0.5. How do you know it's 0.55, right? But you can say with some certainty now. The certainty is that it's between here, right? Anyway, so that's uncertainty, and you'll just see that in your labs. I don't put that on any tests ever. It's just your labs you use that.